Hello. Today I'll be talking about adding and subtracting radicals. The one rule you need to know is when you're adding and subtracting them, they have to have the same index and the same inside, or radicand. Okay? So they have to have the same root and the same inside for you to add them together. Otherwise, you keep them separated, just like 2x plus 2y. You can't do it. So for this first one, we have 8 root 2 minus 6 root 2 plus 5 root 2. That's all right. They all have root 2. So this is like 8x minus 6x plus 5x. It's the same concept. 8 minus 6 is 2. 2 plus 5 is 7 root 2. Done. The inside doesn't change. When you're adding something like 8x minus 6x plus 5x, the x doesn't change when you add them together. Alright, you just get 7x. Right? So here, the root 2 is not going to change. You're just going to get 7 root 2. That's okay. Alright? So sometimes it might not look like you can add them together, but you can break up the insides so you can take something out of it. Right? So we have to simplify these first. 12 can be broken up into 4 times 3. 4 is a perfect square, so we can take the square root of that. 27 can be broken up into 9 times 3. So really what we have here, and whenever you take something out, you multiply it with this. So you take out the 4, because we know we could take the square root of 4. So here we have 5 times square root of 4 is 2. Square root of whatever we can't take the square root of. Can't take the square root of 3. Plus 16 times, we break this up into 9 times 3. The square root of 9 we can do. Square root of 9 is 3. Square root of 3. Well, now they're both square root of 3. So once we multiply these numbers in front, we can add these together. So here, 5 times 2 is 10 root 3, plus 16 times 3 is 48 root 3. So we have our answer. 10 plus 48 is going to give us 58 root 3. Next one. Same thing, but we have a cube root. So we do have to break out 54 into perfect cubes. Notice these are perfect squares. 4, the square root of 4 is 2, the square root of 9 is 3. This is a cube root, so we have to break it up into perfect cubes. We have 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. 27 will go into 54. 27 times 2. Here, we have x to the 4th. It's always good to look at exponents as a fraction with the root, because that tells you how many you could take out. 4 divided by 3 for the x, exponent divided by the root, right? Exponent divided by the root. X is going to give us 1, remainder 1. So we could take 1x out, and we leave 1x in. So far, we've simplified this to a certain point. The cube root of 27 is 3. So we have 3 times, we take out the 3 because the cube root of 27 comes out. And then we have the cube root of whatever we can't take out left in. Cube root of 2x. Remember, we didn't even touch this x here because we can't take out anything from it. Here, we took out 1x and we left 1x in. Remember, it's 4 divided by 3 is 1, remainder 1. So we can take 1x out, we leave 1 in. So here, we have minus. We took out an x, and we have the cube root of 2x. And we do have the same index and radicand. So our answer, we know 3 times 3 is 9. cube root of 2x minus x cube root of 2x, which can be written one different way because we could factor out the cube root of 2x. We can also write this like this: 9 minus x cube root of 2x. It's a little messy, but you get the picture. All right. So I'm going to try to move a little bit faster. Here we can factor. Here we have 4 times x minus 1. Can't do anything with the x minus 1, but you can take out the 4. And we're going to do the same thing for both of these. Here we can take out x squared. We're factoring these. We're factoring the insides right now. So greatest common factor is 4. We take that out. We have x minus 1 left. X squared, take that out. We have x minus 1 left. So here, take out the 4. That becomes a 2. And then we have the square root of x minus 1. Square root of x squared is x, because x times x is x squared. So minus x, square root of x minus 1. And then that's going to leave us with our answer here. We can factor out the square root of x minus 1, so we have 2 minus x, square root of x minus 1. One more. Square root of 9, we already know. That's easy. Square root of 9 is 3. So that's automatically going to turn into a regular number. Minus 45 can be broken up into 9 times 5. And you could take out the 9. So that's going to become 3 root 5 plus 4 times root 125 we break up into 25 times 5. And we could take out the 25. So 4 times 5, root 5. Alright, and then finalize it. Can't do anything with this 3. This 3 is left there. Then we have negative 3 root 5 plus, that's 20 root 5. Negative 3 plus 20 is positive 17 root 5. And I'll circle all my answers for you. Have an answer here, 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 and here. Okay, next. We'll be talking about multiplying, but you do need to know how to add and subtract. That's why this is not in the multiplying section of the video. So, whenever you multiply a number with parentheses, you always have to distribute. So we have 3 times square root of 3 times 4, which is 4 square root of 3. We just like to organize it. Writing it like this can get confusing, so we don't do that. Just write the number in front of the root. Plus, square root of 3 times square root of 3, whenever they're the same root, you can multiply the inside. Square root of 3 times square root of 3 is square root of 9. And then this can be simplified, 4 root 3 plus 3. And you can order this differently. You could say 3 plus 4 root 3. But remember, you cannot combine these because these are not like terms. That's like 4x. So this is like 3 plus 4x. You can't combine like terms. Not like terms. So here, same thing. Distribute. We have the cube root of a times the cube root of a squared is going to give us the cube root of a cubed plus the cube root of a times the cube root of 24a squared. A times 24a squared is 24a cubed. Now, we do know the cube root of a cubed, that's just a. but we can do something with this 24. Since it's a cube root, we're looking at perfect cubes. That would mean 8 times 3. We can take out the 8. So, this equals a, because the cube root of a cubed is just a. 3 divided by 3 is 1. We can take out the 8. That's going to become a 2 out front because the cube root of 8 is 2. We can take out the a cubed. 3 divided by 3 is 1. Remainder is 0, so you don't leave any a's in. So we're going to have plus 2a cube root of what we can't take out. We can't take out the 3. Done. Not like terms. You can't add the a plus 2a. It's not okay. So that's that one. Alright, next one. We know when we square something, we are multiplying it by itself. So that's the first thing we want to do. We have the square root of 3 minus the square root of 2. Square root of 3 minus square root of 2. So we are foiling. So really what we're doing is distributing this to both, and then distributing this to both. So here we get square root of 3 times square root of 3 is square root of 9. Square root of 3 times negative square root of 2 is negative square root of 6. Positive times a negative. Negative square root of 2 times square root of 3 is negative square root of 6 again. And then square root of 2 times square root of 2 is 2 negatives make a positive, square root of 4. We know square root of 9 is just 3. And square root of 4 is just 2. So in the beginning we're going to have 3 plus 2, which gives us 5 minus negative square root of 6 minus square root of 6. So remember there's negative 1 minus 1 is negative 2 square root of 6. And that would be that one. Alright, and the last thing I'm going to cover is rationalizing when there's more than one term in the denominator. And there's one way you have to do it. We call it multiplying by the conjugate. So if we're rationalizing the denominator, we have to multiply by the conjugate of 4 minus root 3, which is going to be 4 plus root 3. And we are going to be foiling those. And if you do it to the bottom, you have to do it to the top. So here, same thing. We're going to be multiplying by the conjugate. Conjugate is just the opposite sign. So the conjugate of root a plus root b is root a minus root b. Do that to the top and bottom. So, first one, we're just distributing the top. 5 times 4 is 20. Plus 5 times square root of 3, can't multiply, so you just write it out. 5 square root of 3. Over. Foil the bottom. 4 times 4 is 16. 4 times root 3 is plus 4 root 3. We have negative root 3 times 4 is negative 4 root 3. And then negative root 3 times positive root 3 is negative square root of 9. The reason we do this is so that these middle terms cancel. And we end up with something that's not a root at all at the bottom. Because this you can't simplify. You're done with the top. 20 plus 5 root 3. Over square root of 16 minus square root of 9 is 3. So square root of 16 minus 3 is going to leave us with 13. Because we know this is just 3. 16 minus 13 in the bottom, it's rationalized. So we can move on to the next one. Distribute. We have square root of a times square root of a. Well, that's the square root of a squared, which is just a. So that's the top minus square root of a times square root of b, square root of ab. Can't do much more with that. You're done. Over square root of a times itself. Whenever you multiply a root times itself, you get whatever the inside is. So we're going to have a square root of a times negative square root of b is negative square root of ab. Same root, you can multiply them, just multiply the insides. A times B, AB. Square root of B times square root of A plus square root of AB. And then square root of B times negative square root of B is minus square root of B squared, which is just B. These cancel. And then we're basically done. A minus root AB over A minus B. And that's all I have for today.